Let's now prove that if z and w are complex numbers, then the modulus of w times z is equal to the modulus of w times the modulus of z. So this is a rule that works for ordinary real numbers and also works for complex numbers. So to prove this, we will do this by brute force. Let w be equal to a plus bi, and let z be equal to c plus di, where a, b, c, and d are all real numbers. Okay, then w times z, if you just multiply it out, would be equal to, and I'll let you verify this, a times c minus b times d plus I times b times c plus a times d. That's what you get when you multiply them together. And therefore, the modulus of w times z is equal to the square root of a times c minus b times d squared plus b times c plus a times d squared. Okay, now let's multiply this out and see what happens. This is equal to a squared c squared minus 2 times a, b, c, d plus a b squared d squared. That's the first part. Second part, when I square the second term out, I get b squared c squared plus 2 times, again, a, b, c, d plus a squared d squared. Okay, now clearly the cross terms are going to cancel out. So on the next line we have, well, let me get the a squared terms together. So I have a squared c squared plus a squared d squared, so that's a squared times c squared plus d squared plus, so the middle two terms have b squared as a common factor, b squared. Then I can factor out c squared plus d squared. So the first and last terms become a squared times c squared plus d squared. The middle two terms I can factor the b squared out, leaving me a c squared plus d squared. Now I can factor out the c squared plus d squared, so I have a squared plus b squared times c squared plus d squared. Now everything here is non-negative, so I can split up the square roots. A squared plus b squared, square root of a squared plus b squared, times the square root of c squared plus d squared. Square root of a squared plus b squared, that is the modulus of w. And the square root of c squared plus d squared, that is the modulus of z. And therefore the modulus of w times z is equal to the modulus of w times the modulus of z, and that is the end of the proof. An alternate way of proving this would be to multiply out the left-hand side when we get this mess here, and we mark it in green. So one way is to just simply get this line here, and then to multiply out the right-hand side here, and just kind of work backwards and show that the two things are equal in the middle. That's also a perfectly valid way of proving this. What's here is a little bit more cleaner because we start from the left and end with the right. That other way would also be perfectly valid.